Welcome to this video about black holes. In this video, we'll take a deep dive into what black holes are, how they form, and what happens when objects get too close to them. Black holes are fascinating objects that have captivated scientists and the general public alike for decades. So, let's get started. Part 1. What are black holes? Black holes are objects in space that have an incredibly strong gravitational pull. Their gravitational pull is so strong that not even light can escape from them. This is why they are called black holes. They don't emit any light, and they are invisible to telescopes. Scientists have discovered that black holes come in different sizes, from tiny ones that are only a few miles across to supermassive ones that are billions of times more massive than our Sun. Part 2. How do black holes form? Black holes form when massive stars run out of fuel and collapse under their own weight. When a star runs out of fuel, it can no longer produce the energy needed to counteract the force of gravity. As a result, the star collapses, and all its mass is concentrated into a tiny space. This creates a singularity, which is an infinitely dense point in space where the laws of physics break down. The gravitational pull around the singularity becomes so strong that not even light can escape it, and a black hole is formed. Part 3. Types of black holes. There are 3 types of black holes: stellar, intermediate, and supermassive. Stellar black holes are the most common, and they form when a star that is about 20 times more massive than our Sun collapses. Intermediate black holes are more massive than stellar black holes but smaller than supermassive black holes. They are believed to form when several smaller black holes merge. Finally, supermassive black holes are the largest and most massive. They are found at the center of most galaxies, including our own Milky Way. Part 4. Event horizon. The event horizon is the boundary around a black hole beyond which nothing can escape, not even light. It's the point of no return. If an object crosses the event horizon, it will be sucked into the black hole and eventually crushed into the singularity. The size of the event horizon depends on the mass of the black hole. The more massive the black hole, the larger its event horizon. Part 5. Spaghettification. As an object gets closer to a black hole, the gravitational pull becomes stronger. This means that the object is stretched out into a long, thin shape, like spaghetti. This process is called spaghettification, and it's one of the most bizarre and fascinating effects of black holes. Part 6. Hawking radiation. Black holes are not completely black. According to the theory proposed by physicist Stephen Hawking, black holes emit a type of radiation called Hawking radiation. This radiation is caused by quantum fluctuations near the event horizon of the black hole, and it causes the black hole to slowly lose mass over time. Eventually, the black hole will evaporate completely, but this process takes an incredibly long time, on the order of trillions of years for a supermassive black hole. Conclusion.
Black holes are some of the most fascinating objects in the universe. They are invisible to telescopes and have a gravitational pull so strong that nothing can escape from them, not even light. Black holes come in different sizes, from tiny ones to supermassive ones, and they are formed when massive stars collapse under their own weight. The event horizon is the point of no return, and objects that cross it will be sucked into the black hole and eventually crushed into the singularity. Spaghettification.